All right, we're still working with improper integrals today, as you probably expected. Okay. We're just going to make one small addition to what we talked about yesterday, and talk about infinite discontinuities at the endpoints. Okay. So this today is infinite discontinuities at your endpoints. Okay. Basically, all this throws in at us is limits from the left and the right. Okay. So let's look at this one. All right, so notice the difference from yesterday. Yesterday we looked at some infinite integrand limit, right? Whereas today, these are not infinite limits, but the function has an infinite discontinuity in it. So this function, if you look at the graph, looks like that. Okay, so if we're integrating from 0 to 9, we have to deal with this infinite discontinuity. Okay. And you have any ideas on how we might take care of that? Limit as. We're going to make it R, as always. What's R have to approach? From the right. It's key. All right. So all you're doing is marking that as a limit from the right side, approaching 0. Okay. It's pretty much the same thing we did yesterday, right? Except this is not an infinite limit anymore. You're going to have to remember how to evaluate limits that are not infinite. Okay. What's the integral of that?
What? X to the 1/2 to my
Negative to
no.
Why is this so difficult? Add 1, divide. Positive 1/2, divide by 1/2. Same as multiplying by 2. Woo! And don't forget your.
Are you live?
Am I alive?
No, live.
Oh yeah, we're online. They've been in calculus for 1.5 years, and they cannot even do an integral. Who is their teacher? Thanks for that. Okay, so we have 2 root 9 minus 2 root r. Yeah? When you evaluate. Yeah. Plug 0 in. Remember your first try on limits is plug and chug. Plug 0 in. What do you get? 6 minus 0, which is 0, or 6. Who is that math teacher? He can't even subtract. Okay. Fair enough? That is it, 6. Okay, so that one would be very straightforward. The thing about these is they're going to present themselves as regular limits, and you're going to have to decipher that this is what needs to happen. Okay, so yeah, what you're looking at is probably anything that looks similar to this with a denominator, roots. Okay. Just a tip there. Okay, you're looking for stuff in the denominator, and there's probably, if you're going anywhere around 0, right, this has an infinite discontinuity at 0, so that would be a clue when we're integrating at 0 that you need to do an improper integral. Okay.
So what if you tried to use that? What would happen?
You would have,
Well, u equals x.
it wouldn't work. Oh yeah, it would work. It wouldn't help you.
What would it give you?
It'd give you the same thing right back.
Oh.
And then it'd just be 1 over root u du. Okay, nice. Okay, another one you could probably look at. Okay, makes the denominator 0, right? So this would be an improper integral. Okay, this is in your book, I think.
Whenever the bottom is 0, that's how you can determine.
That's kind of a clue. Yeah. Let's look at another one. Okay. Where's the infinite discontinuity? Yeah, 1. You plug 1 in, it gives you 0 in the denominator, right? So we're going to have to do 1 from the right. Should it?
Because the right endpoint.
The right.
That's from the left.
Oh, yeah, I wrote it wrong. I was thinking right. Okay, who's that math teacher? Idiot. Okay. We did the last one correct, yeah?
Yeah.
Oh, well, okay. That's what I get for pulling the trigger without asking you guys for consult, right?
It's funny because you use hand signals and stuff, and people watching the video are getting all.
I know I try not to, but yeah. If you look at the graph of this, it's kind of funky. I believe it's -1 and 1. Where are you after that? Okay. So that is the graph of 1 minus, or 1 over the root of 1 minus x squared. Okay. All right. Okay. Do you remember the antiderivative of that? It's a trig function. Which one? Yep. You got it. Again, those are probably like, memorize those, you earn another point. And remember that was like 50 or 60% of students that score on these exams score within 1 to 2 points of that next score up. So that might be the difference between you getting a 2 and a 3 or a 3 and a 4 or 4 and a 5. All right? Can I just plug and chug this? What's the sine inverse of 1? Is that a possible solution? Make sure you're in radian mode. Yeah, what is it?
1.5707.
Oh, that's 5707 is
2 over root 3 maybe.
I'm pretty sure. Okay, remember, when you're evaluating inverses, it's going to give you an angle measure, right? So think here, if this is a no calculator problem, where does sine give you 1? Yes. At what angle measure does sine give us 1? Which is in radians? Pi over 2.
Okay.
1.57. And where does sine give us 0? That's 0. A lot of places, yeah. It is a lot of places. Okay.
What?
That's how you know. We have boundaries. Okay. Any questions? Think you can handle those? There is some stuff we haven't touched here. Oh. Mm-mm.
1.5707? Isn't that what we want?
Hold on.
1.5707.
Pi over 2?
Pi over 2 is outside, is larger than 1.
It is. I might have to think about that then. My suspicion is that yeah, I'm gonna have to think about that.
Well, can the area under the curve be more than 1?
Oh, of course it can.
So then, that's okay.
We're trying to figure out why this is true. This would work though. So this says, right,
Okay, aren't we?
our options.
Looking for an area?
And then we would also do 5 pi over 2. Oh, okay. This is where it repeats because sine only. This is what I'm going to tell you. Okay. Right. That's sine. Pi over 2 is the only place it hits the value of 1 is right there. Okay. It right here, but that's after it repeats. Okay, so we want to stay in here, right? Pretty sure you're not going to see one where they give you that, but I would have to think about that one. Something I've never encountered. So, but that's what I would tell you. Stay in the 1 period. And obviously, we're probably not going to get negatives, but we might. It depends on what they throw at you. Just keep it simple, stupid. That's the theme here. We're in calculus, right? Okay. There is an additional appendage to this section if you want to look at it. They use comparisons. So if you can't calculate the value here of this, there's something you can probably compare it to give it a top boundary. Or it's like the squeeze theorem. Okay, you're going to use some functions and it go between it, but I don't think we need to worry about it. So you have the rest of the hour to work on your homework. Woo, 30 minutes. Let me know if you have any questions. I'll let you know if I have any questions since today obviously is not my day.